Yo, Mr. Lee here. All right, so this is your perfect squares intro. Um, the difference between perfect squares and difference of squares is in difference of squares, your middle term cancels out, right? And then, kind of in the opposite effect, your perfect squares, you're going to double that middle term. Okay, so I'll show you what I mean with the pattern. If I have the square root of 9, that's going to be 3. The square root of x squared is just x. So we can essentially do it like this. 3 minus x squared. Let me write it like this first. All right. So perfect square because we're going to take the same binomial, multiply it by itself. Okay. If you multiply all this out, you should see the middle term kind of double itself, right? So this is going to be 9. This is going to be minus 3x minus another 3x. That's why you get the minus 6x. Okay. And then, your last term becomes the positive x squared. Okay. Another way to write it is going to be like this. Watch closely. Change that just into squared. Okay. Either one should be acceptable by Khan Academy. Let's just type it like that. All right. Here's another area model. So let's find the missing expression. Because it's a perfect square, we just need to find one side length, right? Because one side length times itself will give me the product. Okay. So find the squares. Square root of 1 is 1. Square root of x squared is x. So we're probably looking at a 1 plus x squared. Okay, so let me write that here. You can write it like this. I'll write it in its entirety instead of using the squared expression. 1 plus x times 1 plus x, right? Check it with your distributive property. 1 times 1 is 1, and then you have a 1x plus another 1x. That's your total of 2x, right? So we factored it correctly, and then your x squared obviously on the end. So we just want one side length, okay? They didn't ask you to factor the whole thing, so don't type in the whole 1 plus x squared. We just want a single side length, which is just 1 plus x. All right, last one. Factor as the product of two binomials. So let's see. 81 is a nice perfect square. It's going to have square root of, it's going to be square root of 81 is 9, and then square root of x squared is x. Okay, so we're probably going to have something like this. We can always check our signs as we need. So we're probably going to have 9 plus x times another 9 plus x. Okay, so check your distributive property. Maybe the sign's a little bit off, but I think this one's good. 9 times 9 is 81, plus a 9x, plus another 9x. That middle term combines to that 18x. Yeah? Okay, I'm going to practice typing like this. So there's nothing wrong with entering it like this, but I want to just change it into its squared form. Okay, just to give you guys a little bit of different flavor. And that is your intro.